All right, so we've got two examples from tonight's homework to take a look at. The first is number 17. With number 17 and with all absolute value inequalities, in order to write your two inequalities, you need to have the absolute value bars alone on one side of the inequality. So to do this, I'm going to divide both sides of the inequality by -3. The reason I divide by -3 is because -3 in front of the absolute value bar means that it's being multiplied. So to solve, I divide. My new inequality is the absolute value of 2 minus 5/4 u is greater than or equal to 6. So you might ask yourself, why did she flip the symbol? I started with less than or equal to and now have greater than or equal to. Well, if you recall, with our inequalities, if you divide by a negative, you must switch the inequality symbol. So now that I have my one absolute value symbol by itself, I can create the two inequalities that will satisfy this absolute value inequality. So I read my inequality. My inequality is great or. So whenever it's greater than, I say great or. So I create an or compound inequality. The first inequality of the or compound inequality is just the same as it appears, without the absolute value bars. 2 minus 5/4 u is greater than or equal to 6. The second inequality, just like with equations, you keep the inside the same, but we are going to change the symbol, so it's less than or equal to, and change the sign, -6. Now I have two inequalities that I'm going to solve for. I'll start by subtracting 2 from both sides to get -5/4 u is greater than or equal to 4. And to solve for u, I multiply by the reciprocal, -4/5, to give me that u is less than or equal to -16/5. Again, I had to change the direction of the inequality symbol because I divided by a negative. Well, in this case, I multiplied by -4/5. In the next one, I'll subtract 2 from both sides to get -5/4 u is less than or equal to -8. And then I'll multiply both sides by -4/5 to give me u is greater than or equal to 32/5. Again, I flipped my symbol because I multiplied by -4/5. The graph of this will look like a set of ors. The first portion will be facing in this direction with a closed circle to represent that x is greater than or equal to 32/5. The second portion will have a closed circle pointing in this direction to represent the inequality x is less than -16/5, less than or equal to. And again, these are conjoined with ors, so it makes sense that my graph would look like a set of ors. Here's number 19 from tonight's homework. With number 19, as with all absolute value equations and inequalities, we need to get the absolute value bars alone. So to do this, I need to get rid of the multiplication of 2 and the subtraction of 4. When we solve, we work in reverse order of operations, so I'm going to actually add 4 to both sides first. To get 2 times the absolute value of 1/4 v minus 5 is greater than 7. I'll then divide both sides by 2 to get the absolute value of 1/4 v minus 5 is greater than 7/2. Since the symbol is great or, I'm going to write an or compound inequality. The first inequality always remains exactly the same. The second inequality, you keep the inside the same, change the symbol, change the sign. Now I'm just going to solve each one separately. I get 1/4 v is greater than 17/2 because 5 is the same as 10/2. to which I'm going to multiply both sides by 4 to get v by itself, and I get v is greater than 34. I'll then add 5 to both sides to get 1/4 v is less than 3 halves, because 5 is the same as 10 halves, and then I'll multiply both sides by 4 again to get v is less than 6. So my graph will look like this. V is less than 6, so that's an open circle pointing in this direction, or V is greater than 34, so that's an open circle pointing in that direction. Hope you found this video helpful, and I'll see you tomorrow.